Welcome to today's 5-minute practice problems. This is based on chemistry's number 3 lesson, which is on electron configuration and the periodic table. So, when you're asked questions about electron configuration, often you'll see that you have to do 2 different things at once. And that's often why chemistry is so challenging, is because it requires you to think in 2 different ways at the same time. So, for one thing, you'll be asked to sort of look directly at a periodic table, and then on the same time you'll also have to infer or understand what it's asking without memorizing the periodic table we're looking at. So a very easy question would be, what is the atomic number of carbon? So all you'd have to do is look at your periodic table and say, okay, where's carbon? There it is. Okay, found it. Oh, its atomic number is 6, and then you can look that up. That's a very simple kind of question. We often see with electron configurations where it starts to get more complex, because rather than simply read off the periodic table, you have to interpret the periodic table. So one problem you might be asked potentially would be something like, what is the electron configuration of carbon, assuming it's in its ground state, etc. So in order to do that, you want to try and read the period, rather than just memorize them for every single atom, which I've heard people do occasionally. Please don't do that. You can read the periodic table, understand what the periodic table is saying. So if we start from the beginning, all right, let's make the periodic table. All right, so I'm going to start from the beginning. There's hydrogen, right? Hydrogen starts is our very first atom, and is our very first element, and it's got our first electron, 1s1. And if I go to the next one, is helium. Helium actually belongs in that little notch right next to the hydrogen, right? It's actually, we put it in this group over here because it's one of the noble gases. We'll talk more about that when I get to valence electrons. But for now, let's assume helium belongs in that notch. We can remember it's over there. That's 1s1, 1s2. Then I want to go 2s for the next electrons, 2s1 and 2 for lithium and beryllium. And then I count boron and carbon. Well, I'm in 2p now, so that's 2p1, 2. Right? So the full atomic or electron configuration for carbon is 1s2, 2s2, 2p2. And there's your answer. That's the answer. That's what you actually have to write down. And that's again assuming it's in its ground state, assuming that it's not charged and there's nothing fishy going on. That's the electron configuration of an atom of carbon. You can also be given an electron configuration and be asked what atom or what element does this represent. So for example, suppose I give you this electron configuration, right? So I'm going to go 1s2, 2s2, 2p6, 3s2, 3p4. What does that mean? Well, let's start from the beginning. If you don't have that memorized or don't see the shortcut, you can always just start from the beginning. Hydrogen, helium, lithium, beryllium. Then you go 2p6. That's not in there. You kind of go count through the whole guy, all 6 of these guys, right? Aluminum, or excuse me, we're not there yet. Boron, carbon, nitrogen, oxygen, fluorine, neon, right? Then I go 3s2. Right, those guys over there, sodium, magnesium. Then I go for 3p, I'm in 3p, aluminum, silicon, phosphorus, and sulfur. Oh, that's 1, 2, 3, 4. So, that electron configuration I gave you, this one here again, stands for sulfur, or in its neutral state, in its ground state. So what I mean by neutral is that teachers can sometimes mix it up and give you more challenging questions by giving you ions rather than atoms. So an ion is simply an atom that has a different number of electrons than protons. So for example, rather than giving you just plain old F, I could also actually give you F negative, right? So that means that even though it's still fluorine, because it still has 9 protons. Fluorine is always fluorine because it always has 9 protons. It's the same atomic number. But F negative means it has an extra electron. And often people get this backwards. Keep in mind, electrons, we count them as negative. So if saying F, normally we think negative, take away or subtract. So I've taken off an electron. No, it's backwards. You're adding an extra electron to make it negative. That's a tricky one. Don't fall for that. So F negative. Now normally F would be 1s2, 2s2, 2p5. But I'm adding an extra electron, so it's going to become 2p6, right? The same electron configuration as neon, right? So, one other thing to keep in mind is when you see electron configurations, and I didn't mention this in the lesson, I probably should have, there's often a shorthand, a shortcut to writing it. Right? So for example, if I want to write the electron configuration for sodium, I could write out the whole thing, 1s2, 2s2, 2p6, 3s1. Rather than doing that, I can actually shortcut all of this part here and rewrite that in these brackets as the noble gas directly preceding it, which would be neon. So basically I'm saying neon's electron configuration plus an extra 3s1 that makes it sodium. Now that's the shortcut you'll often see. Alright, so hopefully that clears up how to use this information to answer questions. Alright, thanks for watching. I'll see you guys again soon.